So till now, what we discussed about is is air pollutants and the problems, the global problems associated with that. So we discussed about the ozone layer depletion, then the ice melting, and also uh, the greenhouse gas effect. Okay. So now we will discuss about what are the controlling measures we do for the air pollution. So, so these are the controlling measures. So catalytic converter. So that is basically we use in transportation. So that means that is in every vehicle we have this catalytic converter. Then the cyclone collectors and electrostatic precipitate and scrubbing. So these are the things we use basically in industrial scenario. So the first one is the catalytic converter. So catalytic converter is a vehicle emission control device. So its job is to convert all these toxic gases which is produced during the burning of your natural gases, so that we use in our vehicles. So so that converts from less or more toxic to less toxic. For example, this carbon monoxide is being converted to carbon dioxide, which is less toxic than carbon monoxide. This was developed by the French mechanical engineer Eugene Hundray, and thereon we have different types of emissions rules followed by different countries. So currently we have Bharat 6 or BS6, popularly known as. Then this widespread adoption of catalytic converters didn't occur until more stringent emission control regulations. So initially, no one was bothered about that air pollutants, but later the governments of different countries they realized that we have to control if we want to control the air pollutions. So they start with controlling the or fitting different types of catalytic converters in different vehicles. So then also they change the 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 composition of of your natural oil or the petroleum that we use in our vehicles. So lead is an anti-knock agent, so that has also been removed because that acts as a catalyst poison actually. So that you know uh, that is being covered in your chemistry course. How different types of catalysts. So poison catalysts, what happens? They got absorbed on the surface of the catalyst and decreases the lifespan as well as the catalytic activity of catalyst. So in this category, the first one is the two-way catalytic converter. So this two-way catalytic converter converts the carbon monoxide to carbon dioxide and the hydrocarbons. So that is basically the petroleum. So that is being converted to carbon dioxide and water. But the two-way catalytic converter is not able to convert the nitrogen oxide. So that is also vital air pollutants. So with the time, the three-way converters are being adopted. So the job of the three-way converter is first it converts the nitrogen oxides to oxygen and nitrogen, and the rest of the two is similarly done in a three-way catalytic converter. That is, the carbon monoxide is being converted to carbon dioxide, and the hydrocarbons is being converted to carbon dioxide and water. So I will run. There is a small video. So on this, I will just run a video. So just follow that. Uh, you may not get the sound from that video, but that is not that necessary. So everything schematically describe how the 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 pollutants the pollutants are being converted by the different catalyst that is present in this catalytic converter. So let me show you that. Here the nitrogen oxide is being converted to oxygen and nitrogen. Okay. So here carbon monoxide is reacting with oxygen. So that is the first part and being converted to carbon dioxide. Yeah. So finally, so your all the toxic pollutants that is carbon monoxide is being converted to carbon dioxide. Your nitrogen oxides will be converted to nitrogen gas and oxygen, and the hydrocarbons, the unburned hydrocarbons, will be converted to carbon dioxide and water. So, although at the end we'll be releasing the CO2, but CO2 is less harmful as compared to your carbon monoxide. But again, the accumulation of CO2 is not also good for the environment. So that is why this is the reason why we are moving towards more EV vehicles. So in future we'll have more EV vehicles and maybe the fuel cell technology. So which if you see the fuel cells reactions, so the end product is just pure water. So from an environmental point of view, fuel cells, the batteries are more acceptable in comparison to burning a natural uh, petroleum. Okay, so let's go back to our discussion. Okay, so the next slide would be discussing about the details about that you see here. Uh, okay. So about the catalyst, so here there are different types of noble materials are being used. So platinum, palladium, rhodium, cerium oxide. So, or the combination of all these noble materials like platinum, palladium, or platinum, rhodium. Okay. So, also the catalyst from lanthanum series and also being used like cerium oxide. So, but these are very very expensive materials. Okay. So, many researchers have been working on how to find out a, a cheaper method, okay, for this catalyst because these noble metals they are very stable in normal environment uh, like in that the temperature that we operate in the vehicle, so they are very stable so they do not get oxidized, but they're in general they're very expensive. So but also if you see the catalytic property of these metals, so it can be done with one or two layers of these metals. So one or two layers means I'm talking about in some micron region or nano nano level. So one or two layers means hardly in the range of like 100 or 200 nanometers of these materials on top of copper or any cheaper material would be enough to act as a catalyst. So you don't need a bulk of platinum or palladium. So research is also happening in that series. Also, the new materials are being developed, find way to used as a catalyst for this kind of systems. Then the slide is describing that you saw in the video. So there are two parts. So the first part, the nitrogen oxide is being converted to nitrogen and oxygen. Then in the second chamber, the oxygen will react with carbon monoxide to give you carbon dioxide. At the same time, the hydrocarbons will be converted to carbon dioxide and water. So this is how the catalytic converter works in our vehicle system, and this is a mandatory part of each and every vehicle nowadays. Again, like also we have this different environmental policies. So for vehicles, now we are following this Bharat 6. So the idea is to reduce the amount of release of carbon dioxide, or if any other toxic gases to the environment. So that's why we have different environmental policies for the vehicles, and maybe in future it will be completely obsolete from that series. We'll be using only the EV vehicles, or the sources, or green sources, for example, the fuel cells technology. Okay. So the next one is the cyclone collector. So this is a very simple mechanism. So what happens? So the dirty air enters from this side, and they are being rotated in this cylindrical, uh, uh, big cylindrical tubes. You can say that. So the denser particles, so they will collide with the wall and they move downwards, whereas the lighter particles will come to the center and move upward. So more cleaner air will come out from this tube. Uh, in terms of efficiency, if you see, so it can almost remove 50% of dust particles. So this is a purely a physical separation of uh, pollutants from air. So there's no chemical reaction is going on as it does in your catalytic converter. So this is just a pure physical separation method, and the mechanism is very simple. This can be done in a home environment, but the use of this kind of devices uh, is very less. These are limited to industries where the the chances of releasing bigger particles or debris to air. So there you can separate all this light, bigger particles, which are the pollutants, so that can be removed from air. Uh, as I told you, the efficiency of this kind of cyclone collector is limited to 50%. So it's just a physical separation, nothing more than that. Next is the electrostatic precipitator. So the electrostatic precipitator works in this principle. So if you see the schematic, so what happens? You have two electrodes, the blue ones and the red ones. The blue ones are the negatively charged. So when the waste gases containing smoke particles pass through this, okay, so what happens? So they're being charged. So the particles being charged, negatively charged. Then the red electrodes that were biased at positive potential, they will attract all these negatively charged particles towards.
आपका हो गया पैकिंग
Yes. Then they will be deposited on this red electrodes. Then timely a mechanical way scrub it and collect it and throw it away. And then again, the surface is exposed for the collection of this charged particle. Very simple mechanism, and a series of ESPs are being used in industrial level to remove the smoke particles. So they are limited to industrial environment. Then comes this wet scrubbing. So wet scrubber is used for cleaning the exhaust gases from various pollutants such as water-soluble toxic or corrosive gases like HCl and ammonia or particulates. So wet scrubbing works by the contact of target compounds or particulate matter with the scrubbing solution. So this is a pure chemical reaction is happening between uh, the pollutants and the target material. The job of this target material is to absorb this and be a product water, and that can be washed away. So there's also a video on this. So I'll just run it to get a clear idea about how the scrubbing works. So there are two types of scrubbing a technique: the wet scrubbing and also dry scrubbing. When in case of dry scrubbing, what happens? The target materials can be soaked in a surface. So when the gases pass through that, they will react with that. They get absorbed on those target materials, and finally they washed out with pure water. So I'll just to run a video regarding this. So maybe we'll get an idea how this wet scrubber works.
Excuse me, sir.
Yes, below.
Sir, rule number 749, sir. Due to electricity problem in our area, sir, I joined class little bit late, sir.
Okay, we'll address this later. First, attend the class. Okay.
Okay, sir.
Okay, so this is about this wet scrubber, how it works. So let me run the video. Sorry. So what happens here basically that the exhaust air enter into that system. So then they are being exposed to some chemicals. So if it's your pollutant is an acid, so the they expose that to some base material so that it will react with the acid material and they gets neutralized, and finally they've been collected at the bottom of the system, that is with water, and finally they will be removed that. So depending on the requirement, there are different types and different designs of wet scrubbing systems, but these are very much limited to again the industrial and scenario, or not in for the domestic purpose. The dry scrubbing also the works in a similar fashion, but here you have a bed of materials which are soaked with uh, some some target material, for example, the hydrated lime or soda ash or sodium bicarbonate. So they are being exposed to the gas stream, so the exhaust gas. Uh, then if the gas stream has some acidic component, so they will react with the base component and being neutralized. The advantage of this kind of system is that the efficiency of this systems is almost it can go up to 80%. So it can clear out 80% of the pollutants from the air, and the air would be free from almost all the toxic gases, nearly up to about 80%. Yeah. So these are the methods that we use for the air to tackle the air pollution. Nowadays, it's very common in home environment. Also, you see the all this air purifier. So the function or the mechanism of all this air purifier also based on on this concept. So maybe nowadays they have the advanced the carbon based materials which can absorb different types of uh, uh, pollutants. So and it is very common nowadays, particularly in bigger cities, so where the air quality is very very low. So it's almost a must-have device at home environment to get cleaner air. The small cities like here in Odisha, it is the air quality is not that bad still because these areas are not industrial areas. So still the air quality is better in comparison to some bigger cities where the industrial activity is more. For example, in southern side, also the western side, and also northwestern side, where the industrial activities is more, and the air quality is really really poor, particularly in Delhi area. The next we'll be discussing about the water pollution. So go to that slide. Yeah. So the water pollutants in this category, we will be discussing about the organic pollutants, the inorganic pollutants, the sediments, the radioactive materials. Then comes the thermal pollutants. So in organic pollutants categories, we have oxygen demanding waste. So that is basically the sewage. Then we have pathogens, then plant nutrients. Then we have synthetic organic compounds. So that is basically comes from your the industrial activities. Then oil spill. The oil spill is a very rare event, but that happens also many times. So in case of oxygen demanding waste, so we have sewage that is the main contributor for this organic pollutants. Then we have industrial waste from food processing plants. Then we have the material industries like paper mills or tanneries. Then waste from slaughterhouses. Then runoff from agricultural lands. So these are the waste which demands oxygen. So what does that mean? For the decomposition of this organic pollutants, they use oxygen. So by using that, so they decrease or they remove the oxygen from the water. So for that, uh, when they end up in some closed water body system, so decrease in oxygen leads to different types of aquatic the problems for aquatic animals as well as the aquatic plants. So then the pathogens. So pathogens are the microorganisms. In this category, you have bacteria, viruses, protozoa, parasitic worms. So these are very, very harmful for human health, due to which we may have different types of diseases like typhoid, cholera, dysentery, polio, infectious hepatitis. So all this type of diseases can happen due to this pathogens, which comes under this organic pollutants. Uh, Nutrients, so mainly provided by the sewage and the runoff from agricultural lands. So excess nutrients leads to eutrophication. So eutrophication is basically it's covered by all by this weed and algal blooms, and which blocks the diffusion of aerial oxygen to the water. So due to which, so there is a depletion of oxygen level in this water bodies. So which ultimately leads to, to again a problem for the aquatic animals as well as aquatic plants. Again, nutrients like nitrogen is basically commonly available as nitrate in water. Then the nitrate is being converted to nitrates, so which replaces the oxygen in hemoglobin. So due to which, what happens that in case of infant, when the mother is exposed to this water with a nitrite, so the baby has this bluish discoloration. So it's commonly known as blue baby syndrome. So it happens when your water is polluted with nitrates. Then the synthetic organic compounds. So all these industrial activities to fulfill our demands, daily demands, for example, the plastics, plasticizers, fibers, elastomers, solvents, detergents, paints. So these are all the materials that we use almost daily basis. So this comes under the synthetic organic compounds. Again, if they end up in some water body system, they provide it's very offensive taste and odor, and also the color. So even a very small concentration of this chemicals, I would say, is very harmful for the human health. Then comes the oil. The oil in terms of organic pollutants. This is a very rare event, basically. So the leakage from or the accident happens in sea, that is from the cargo tankers. They and the leakage from oil pipelines, because the pipelines are spreaded over below the sea level. So if any leakage there is leads to catastrophic oil leakage. So what happens due to this oil spill? So they since oil is lighter, so they comes to the top of the surface and they blocks the surface of water, which again blocks the diffusion of aerial air to water and reduces the dissolved oxygen. So decrease in dissolved oxygen leads to different kind of marine problems. So the next is the inorganic pollutants. So in the inorganic pollutants are basically consist of inorganic salts, mineral acids, finely divided metals, and metal compounds. So mainly in inorganic pollutants, acid mine drainage is one of the common problems. So that's basically what happens. Uh, Acids are being released to water, and they end up in closed water body system. So this happens due to this iron sulfide, which is known as pyrite and commonly known as fool's gold due to its color. The color is almost very close to how the gold looks like, so that's why it is known as fool's gold. So, and this is a major problem for the mining sites, and since the sulfides are very common in ores, so iron sulfide is a very common compound to be found in different mines. So, what is the basic reactions of and how the acid is being released to the water system? So, this slide is describing that. So, what happens? The pyrite is being converted to iron 2 and sulfate. So, here sulfide is getting oxidized to sulfate, and once you have sulfate, so it can dissolve the iron iron 2. Okay. Now, once you have iron 2 in the solution, okay, in water, so they have a tendency to be oxidized. So they take the H plus ions and the oxygen and being converted to Fe3 plus and H2. Now, once we have Fe3 plus, which is being dissolved in the water system, so it has also an oxidizing capability, which can also oxidize the pyrite. So it works as a chain reaction. So if you see the second and third reaction, so it will uh, it will go on and it will generate lots of hydrogen ions. So overall, if you see, 16 H plus are being generated from one FeS2 molecule. So high release of H plus ions decreases the pH value. So decreasing of pH value means the water becomes more acidic, and once this acid water is being ended up in closed water body system, so it changes the pH and affects the aquatic uh, animals. So this is how the acid mine drainage looks like. So this is a stream coming from an old mine, and you can see the whole path of water. is being deposited with iron S2. So pyrite, and that the color of this is very much close to gold. Next, the inorganic pollutant is your sediments. So the soil erosion gives rise to different sediments in water, and also the agriculture activities, construction, mining activities also leads to different types of sediments, and they are indirectly or directly affecting the erosion rate. Sediments are basically acts as the repositories for trace metals, different types of metals, so calcium, magnesium. All these metals are being deposited in these sediments because sediments have higher surface area, so all this traces metal can be deposited there. Then we have radioactive metals, which is it's not that common in terms of inorganic pollutants, but it does happen because we have also the mining or ore processing where the radioactive materials can be found. But besides that, we have also the nuclear power plants. And also in medical diagnosis, we also use some radioactive materials, particularly in treatment of cancer. Then also the radioactive materials are being used in research applications and also testing nuclear weapons. So these are the sources for the release of radioactive materials to water system. So the common radioactive materials that is found in water is potassium 40, and then strontium 90, in iodine 131, barium 140, cobalt 60, manganese 54, plutonium 239, radium 226. So these are the common radioactive metals that is being found in water as an inorganic pollutants. The next is the thermal pollutants. So this is again limited to certain areas, for example, the thermal power plants and the nuclear power plants. So what happens? The thermal power plants and nuclear power plants, they use the water from the nearby river or lakes as a coolant, and the wastewater, which is has a higher temperature, they are being released to the same river or the closed water body system. So normally, what we see here that the this leads to almost 10-degree rise in temperature. So 10-degree rise it's a it's a very high rise in water, and that ultimately decreases the dissolved oxygen and also leads to different types of problems associated with aquatic animal as well as the plants. But this is very much limited to the those areas where we have nuclear power plants or thermal power. Okay, so this is about the water pollutants. So the organic pollutants as well as the inorganic pollutants. So the next would be the remedies or the treatment that we do for uh, water treatment. Okay, so before we release this water or the polluted water to river or lakes, so what are the different treatments we follow in current scenario? So there are different stages of treatment techniques. So that we will discuss in the next class. Then finally, we will discuss also uh, the modern or current techniques that we are using as well as in industrial level as well as at home. So for water treatment. So for today's quiz, it would be the the remedies or the techniques that we use for air pollutants and also uh, the water pollutants or the sources for water pollutants. Okay.
Yes, sir. So the timing will be that same, na? 10:30.
Yeah, 10:30 would be the timing. So maybe last time some few of the students were not able to access that link. So this time I'll provide you two links. One is the extended link and one is the short link. So I believe you can access any one of that. So it won't be a problem.
Yes, sir.
Okay.
Sir, excuse me, sir.
Yes.